right. Um, it is very, very similar. Adding rational numbers is going to be very similar to when we were adding integers, negatives and positives. We're going to start with number lines, just like we did with integers. The difference is we're not dealing with just negative and positive whole numbers. We're also going to be dealing with decimals. So our first example is going to be 1.5, 1.5 plus 2.5. Now most of us can do that in our heads, but what I want to do is I want to represent it on a number line. So we have 0, and then I'll do 1, 2, 3, 4, 5, and then I'll do the other direction too. 1, 2, 3, 4. Now this is how the book does it, so I want you to be familiar with this. I think if I was using graph paper, I would probably skip every other one. So it would be half, 1, 1.5, 2, 2.5, 3, probably like that. But here I wanted to save some space, and also in your textbook, this is how it's written. So our first number is 1.5, so starting at 0, we're going to go 1.5 in the positive direction. That puts us right there. Okay, halfway between 1 and 2. Then I'm going to add to it 2.5 more. So here's 1 more. Notice it's going 1 unit more, so now it's at 2.5. So I have to do 1 unit, 2 unit, and then half another unit. Which puts us at 4. Let's look at fractions. So for this one, I am going to make it a little bit bigger to make it easier to read. For this one, I want to add negative 3/4 plus negative 1/2. So I'm going to start at 0, and I'm going to go 3/4 in the negative direction. Here's halfway. Where would 3/4 be? Right, it'd be right here. If I were to break this up into 4, there's 1, 2, 3/4. So that'll put it right there. And then I have to go another half in the negative direction. Well, half is one of these bars, so it'll be right there. Okay. So what do I get if I add that? Negative 1 and 1/4. Number lines, I think, are really messy when we try to use fractions and decimals. Number lines work really, really well for integers, but they make it kind of messy for rational numbers. The reason that we use number lines is to prove why things work. It's not just random things that we're doing in math to make it work. This is showing why it works. Let's look at another one. This time let's do 4.5 plus negative 3.5. So on our number line, we'll do another one that's spread out a little bit. I just think they're easy to read. So again, we'll start at 0. And we're going to have to go 4.5 in the positive direction. 1, 2, 3, 4.5, halfway to the next one. And that sign in front tells you what direction we are going. So now we're going to go in the negative direction. So starting at that point, now we're going to go 3.5 in the negative direction. Here's 1, 2, 3, and then a half. Put this right there at 1. So again, the whole point of the number line is to prove why things work. But it is not the most efficient. Let's say I've got so I've got negative 8/7500ths, and I'm adding to it 4.5. Now the trick to doing problems like this, which is where we struggled before, our signs are different. If our signs are different, you do big minus little, and then you use the big numbers sign. That is, if our signs are different, we do the big number minus the little number, and we keep the big sign. The big being the absolute value larger number. So the absolute value is 8.75, the absolute value is 4.5, so this is going to be our bigger number. So I'm going to do 8.75. I'm going to add to it, but since our signs are different, we have to subtract big minus little. So we're going to subtract 4.50. Notice our decimals line up. So our decimals are going to line up, and then we subtract. 5 minus 0, 7 minus 5, 8 minus 4, and then we keep our larger sign, so it's negative. So our answer is negative 4.25. One-fifth plus negative 1/4. How can I add those two together? How am I going to add those fractions? Have we studied converting to decimals? Is that something we should be able to do? Yeah. Let's do it. So I'm going to convert both of these to decimals. Decimals are so much easier to work with. So let's do that. So 1/5 is a decimal. It's a benchmark fraction. We should know what that is. 5 goes into 10 2 times. 5 is 10. So 1/5 is going to be 0.2, and then negative 1/4, also a benchmark fraction, we should know that one. 8 quarters and 25. So negative 0.2. So our signs are different. Because our signs are different, am I going to add or am I going to subtract? Subtract. I'm going to do the big number minus the little number. Which one of those is the bigger number, though? Right? Yeah, if I line those up like this, they're tied right here. But here, this has got a 5 and then that's got a 0. So that one's going to be bigger. I'm going to do my big minus my little, so 0.25. Then I'm going to subtract 0.2. Notice they're lining up. 5, 0. 0. Oh, I'm sorry, hence the 5. So our answer there is 0.05. And is it going to be negative or positive? Negative. Let's do one more. Let's do 1 and 1/4 plus 2 plus 1. I'll give you a minute to solve that one. So I want to build on something else we did earlier in the year. When I see this, the first thing that comes to my attention is I've got two fractions here, and I got a whole number here. It's always going to be easier to add that whole number, so I might want to wait till the end. What you can use is the associative property. By using the associative property, I can add these two things together first. It might make the problem a little bit easier. 1/4 is a benchmark decimal, so we have 1.25 plus, and then I'm going to do that, 0.25. Then I'm going to add my 2. Different problems are different. This one happens to be easier if I add those two together. When I do that, I get 1.5. Then I add on my 2, which gives me 3.5. It's just a way of making the problem a little bit easier. If you do not convert your fraction to a decimal, you can always find common denominators, which is, again, something else you've done. However, everything that we've done is turning fractions into decimals, so turn them into decimals. It makes things a little bit easier. Any questions about that stuff?